This is the second part of our video for section 8.2 on parallelograms. We're going to use those two theorems we looked at in the last section. Theorem 8.3 told us that if you have a parallelogram, then the opposite sides are congruent. Okay, notice this shape looks like a parallelogram and it has the markings that indicate that it has to be a parallelogram. So if the bottom's 12, the top has to be 12. That should make sense then that x is 8. Now we don't know anything about the left side and the right side, and that's okay. We need to find y. Notice how the angle on the bottom left is 65 degrees. Its opposite angle would be the angle in the top right. That's the angle that's got the y there. So that's got to be 65. Simple. We use theorem 8.3 and we use theorem 8.4. Here's a couple other easy examples. We want to find the distance from F to G. That's the left side. It's going to be the same as the right side because this is a parallelogram. Angle in the top right is 60. The angle in the bottom left is going to be 60. Remember, 360 degrees in a parallelogram. Also, consecutive interior angles are supplementary when you have parallel lines. So the 120 comes from 180 minus 60. Okay, so if you're going to write it out, distance from F to G is 8. Measure of angle G is 120. Example at the bottom there, that's also a parallelogram because of the markings, not because it looks like it. That right side has to be 18, so I'm going to say that y is 15. Angle L is 50 degrees, so angle M has to be 130. So what times 2 gives you 130? 65. Those are easy examples. Theorem 8.5 basically is what we've been talking about for the last few slides. When you have a parallelogram, the consecutive angles have to be supplementary. So in this particular example, x plus y is 180. And I can see I already have that written down here. Okay, so let's use that to our advantage here. We have a desk lamp. As shown, part of the extending arm of a desk lamp is a parallelogram. So we have this little parallelogram figure down here. The angles of the parallelogram change as the lamp is raised and lowered. Find the measure of angle BCD. So if I just draw an enlarged version of this parallelogram, and I'll try to label this a little more accurately than I was starting to. We'll call that guy B, C, D, and call that guy A. If angle ADC is 110, what's the measure of angle BCD? That would be this guy. It would be 70. It's just a supplement. Theorem 8.6 tells you something new. If you have a parallelogram and you draw both diagonals on the shape, the diagonals actually bisect each other. Okay, so that's kind of useful. You also know that you have some vertical angles here. So if I was to call this little triangle, triangle 1, and this little triangle, triangle 2, does it make sense that the triangle on the left and triangle on the right are congruent by side angle side? Okay, now same thing with the top and the bottom. I would call that triangle 3 and that triangle 4. The triangle on the top is going to be congruent to the triangle on the bottom. So if you know any information on any one of these little triangles, you can transfer that to another little triangle that you know is congruent to it. Okay, we'll check out this example here. The diagonals of this parallelogram intersect at point P. What are the coordinates of point P? Well, they're telling you that this is a parallelogram, which is nice. But they didn't have to because it's in a coordinate plane. You could determine that the top and the bottom are parallel because they're horizontal. And you could also determine the left side and the right side are parallel because they have the same slope. Remember that. Okay? If the diagonals bisect each other, we're using that theorem 8.6. That means segment LP and segment PN are the same. So wouldn't P be the midpoint of segment LN? Remember how to find a midpoint. L lives at, looks like 1, 4. N lives at 6, 0. What point is directly in between L and N? Remember, we're basically averaging a 1 and a 6. 1 plus 6 is 7, and 7 divided by 2 is 3.5. Notice how it's not written as 3.5, so 7 halves, it looks like your guy. What's the midpoint of a 4 and a 0? That 2 is. So that's going to be where P lives. Now remember, you could have done it going this way as well. That diagonal also gets bisected. So you could have found the midpoint of segment OM if you wanted.